prediction market platform, while at the investment firm Winton Group, where I worked for a decade, therefore with a solid experience in developing such prediction market platform. And at Evermind, also a technology company, spun cut from Winton in 2018. He has a PhD in planetary science from Tech for a thesis on predictability of El Nino, therefore a good knowledge of what it means to predict. And at Winton, he led the integration of weather and climate information into quantitative trading strategy. And Mark is now a senior research fellow at Lancaster University, where he is director of operation for the Crucial Initiative, which is supported by SCOR. Of course, I wanted to develop a little the career of Mark because it gives some light on what you will hear in a few seconds and what you will be listening to. In this webinar, Mark and Kim will describe several structural challenges that affect climate forecasting, especially all the uncertainties concerning the modeling of climate. And therefore, as we have known from the financial markets, there is a lot to learn from a predictability market, which is going beyond this uncertainty. Therefore, we try to reduce the fundamental uncertainty in our knowledge by a certain expert judgment, which is something which is not only applied, as some of you can remember, not only on predictability market platforms, but for example, also for some internal model when we are confronted with very exceptional extreme events. Kim and Mark will introduce Crucial, an initiative that is funded by the SCOR Foundation and that use prediction markets with expert participants from academia and the private sector to generate collective probabilistic forecast of climate-related risks. They will therefore describe Crucial plans to become a new type of scientific institution for synthesizing climate forecasting modeling and expertise, and as a mechanism for allocating funding for climate research in a performance-driven way. Of course, I will stop there because you are not here in order to listen to me, but to listen to Kim and Mark. Just may I remind you, we will have a presentation in between 45 minutes and 60 minutes, and thereafter a Q&A. And in any case, we will stop before 4:30, so that we don't take too much of your time. And moreover, may I recommend to you to ask only very technical questions during the presentation, that is question of understanding, and to delay your question concerning the discussion, the questioning, the challenging for the Q&A session at the end of the presentation of Kim and Mark. Kim and Mark, we are very thankful not only for your initiative, not only to have given us the opportunity to support such an initiative which is promising, at least from your point of view, but also to have accepted to present a very relatively pedagogical presentation of Crucial, so that everyone, especially at SCOR, but also among clients and among academics, are now well informed on that topic, and not only well informed, but also following and thereafter maybe participating. Please, Kim and Ma, you have the floor, and thank you so much.
Thank you very much, Philippe, and so thank you for that introduction, and also thank you to the SCOR Foundation for funding this initiative. So the webinar has been split into 6 parts. First, we'll describe the specific challenges in climate forecasting that we're trying to address with Crucial. Then we'll describe prediction markets, which is the core technology that Crucial uses. We'll talk about the liquidity problem, which is something that has hindered the use of prediction markets for more specialized topics, including climate, and we'll describe how we deal with it. And then we'll discuss Crucial, what it is, what it's currently doing, and finally, what we plan to do with it in the future. So there's lots of scientific challenges that face climate forecasting, such as modeling the impact of warming on clouds and clouds on warming. But the challenges that we want to talk about are not so much scientific challenges, but they're structural challenges. They're issues about how the enterprise of climate forecasting is organized, how it's managed, and how it's incentivized. So a major challenge faced by climate forecasting is that it requires a huge range of expertise, which is spread across many different disciplines. Predicting future climate, if you're given future concentrations of greenhouse gases, if you can assume future concentrations of carbon dioxide, that requires expertise in meteorology, in oceanography, and other physical sciences. Now, a lot of this knowledge is codified in climate models, but experts also have more tacit knowledge, such as what the strengths and weaknesses of these climate models are. And this tacit knowledge is much harder to capture and to quantify. There's also different modeling approaches. So traditionally, climate has been modeled using global circulation models that simulate the ocean atmosphere system using the laws of physics. But recently, they've been joined by techniques that are more based on machine learning and AI. And the best way to combine these new methods with the more traditional methods is still an open question. Forecasts of future climate, given future concentrations of greenhouse gases, are useful for informing policymakers about what kinds of emissions reductions are needed to keep global temperatures below certain thresholds. However, if you're planning to adapt to climate change, you need unconditional forecasts of climate. So we also need to predict, at least probabilistically, what those future concentrations of greenhouse gases are likely to be. And this expands the range of expertise that's required because it requires knowledge about social sciences, economics, policy studies, and the likely path of technological innovation. So that's the first challenge. Another challenge is something known as information asymmetry. Weather forecasters who produce short-range weather forecasts, maybe 1 or 2 days ahead, they can build up a statistically meaningful track record in a few months to demonstrate that they have skill, to demonstrate that they know what they're doing. Now, if they are producing seasonal forecasts, that means they're producing forecasts for a few months ahead. It takes longer for them to build up a track record of truly out-of-sample predictions. And if they're producing long-range climate forecasts that could have prediction horizons of decades, then they won't be able to show users that they have skill before those users have to use their forecasts to make decisions. This is a situation of asymmetric information in which the buyers or the users of the forecasts can't verify their quality before choosing a forecast provider. Now, back in 1970, the economist George Akerlof wrote a famous paper about this type of situation where he used the market for used cars as his example. And in the US, lemon is a slang term for low quality used cars. So these kinds of markets have become known as markets for lemons. And he showed how in a market where buyers are reticent to pay for quality that they can't verify, and sellers don't want to invest in quality they can't demonstrate, the market can enter a so-called death spiral of declining quality and declining prices. The growing market for climate analytics, in which users pay upfront for risk forecasts that might not be verifiable for years, is vulnerable to exactly this kind of problem. One suggested solution to this textbook mode of market failure is for sellers to offer warranties on quality. And these warranties can allow the sellers to credibly signal how much confidence they have in what they're selling, and it can give buyers the confidence to buy them. Another challenge is that climate forecasting also shares a problem with inflation forecasting that's been called circularity. Inflation at least partly depends on interest rates, but central bankers use inflation forecasts to help them decide on interest rates. And similarly, future climate depends on greenhouse gas emissions, but these emissions at least partly depend on policies, and policymakers take into account climate forecasts when deciding on policies affecting greenhouse gas emissions. So climate forecasters have historically produced climate simulations that are conditioned on particular pathways of emissions, but without assigning probabilities to these pathways. But as I mentioned, adaptation planners need unconditional forecasts of future climate. What is the climate going to be like? Not what it's going to be like assuming some level of greenhouse gases, which means probabilities have to be assigned to these greenhouse gas emission pathways. So prediction markets offer an elegant way of simultaneously addressing all of the three structural challenges that I've just described. So prediction markets are markets that are specifically designed to exploit the ability of markets to reveal and aggregate information. Now, lots of financial markets, such as the stock market and commodity futures markets, they perform information discovery as a side effect of their main job, which is allowing the transfer of assets or the transfer of risks. But for prediction markets, this information discovery role is the primary job. So prediction markets essentially use the mechanics of betting as a way of eliciting and combining the judgments of participants to produce unified probability forecasts that reflect the collective expertise and knowledge of the participants. Prediction markets can help the fragmentation problem by the way that they aggregate expertise, and they avoid the need for forecast users to select a single forecaster. Because even if they could decide who the best forecaster is in advance, it could be the case, and is often the case, that the best forecast includes information from multiple forecasters. Prediction markets can also naturally solve the incentive problem because they can reward participants based on the contributions that they make to the accuracy of these collective forecasts. And this allows participants to signal how much confidence they have in the information that they're injecting into the market. And we'll also see how we can use more sophisticated prediction markets to address the circularity problem by allowing joint forecasts of greenhouse gas concentrations and climate variables to be generated. So most prediction markets use contingent securities, and these are just conditional IOUs that pay out 1 unit if a specified event occurs. For example, one might pay out €1 if it snows in Paris on Christmas Day. And these types of securities are sometimes called Arrow-Debreu securities, after the economist Kenneth Arrow and the mathematician Gerard Debreu, who did a lot of work on the complete markets and these kinds of securities. Kenneth Arrow, although he was an economist, during the Second World War, he actually served in the US Army Air Force as a weather officer. And there's a story that weather forecasters had been asked to provide month-ahead forecasts by HQ. And when Kenneth Arrow analysed their skill, he found that they didn't have any. So the weather forecasters asked HQ whether they could stop producing these month-ahead forecasts. And HQ responded that the commanding general is well aware that the forecasts are no good. However, he needs them for planning purposes. So anyway, prediction markets are based on these contingent securities. And if these securities are traded, And if their price equals their expected value, then we can interpret that price as the probability that the event will happen according to the collective wisdom of the market. Now, when you buy one of these securities, it's exactly the same as fixed odds betting. So, for example, if I pay 25 cents for a contract that will pay out €1 if a specified event occurs, then that's the same as placing a bet at 3-to-1 odds against of that event happening. But in a prediction market, these securities are continually traded, so prices can adjust as participants receive new information. And this is what allows prediction markets to assimilate new information and insights in real time. Now, the earliest academic prediction market was created by the University of Iowa in 1988, and it's called the Iowa Electronic Markets, or IEM. Now, its focus is predicting elections, mainly American elections, but also elections of other countries. This plot shows a market that they ran for the recent Canadian federal election. So there were 3 contingent securities, each of which would pay out $1 if each of the 3 major parties won the most seats, and a 4th one that would pay out $1 if none of the 3 major parties won the most seats. And you can see how the price of these securities changed. Back in March, the Conservatives looked most likely to win. Their contract was trading at about 75 cents. But stuff happened, and the Liberals surged in popularity, with market prices implying that they had a more than 90% chance of winning the most seats on the eve of the election, which was at the end of April. And they did indeed win the most seats and win that election. Now, creating the Iowa electronic markets wasn't straightforward from a legal standpoint. Gambling in the US is regulated by the individual states, and it's illegal in many states. And betting on elections was prohibited when the IEM was created. Futures trading, on the other hand, is regulated by the US federal government, by the Commodity Futures and Trading Commission. And because it was an academic project, the IEM managed to get a dispensation from the Commodity Futures and Trading Commission that said that if they limited the stakes to $500 per participant and limited the number of participants to 2,000, then the CFTC would leave them alone. So for a long time, the IEM was the only US-based platform where you could place real money bets on the outcome of elections. Now, the researchers behind the IEM were motivated by wanting to study markets, but other scientists have considered whether prediction markets, as well as providing information about how predictions are formed, can actually predict things of direct interest to science. This slide summarizes a study by a group of researchers as part of the Replicability Project, which studied whether published studies in experimental social psychology would replicate if they were rerun. They chose 41 studies to be rerun as part of this project, and they set up a prediction market in which experts from social psychology could essentially bet on whether each study would replicate. In other words, would a positive result be obtained again if the study was rerun by different researchers using new subjects? The squares in the plot show the market prices for each of the studies, ranging from 0 to 100. The red ones are the ones that did not replicate, and the black ones are the ones that did. The prediction market approach outperformed surveys of the experts, whether they were simply unweighted surveys or whether they weighted the survey responses based on the expertise of the experts. In 71% of the replication studies, the most probable outcome, as implied by prediction market prices, was the one that occurred. And this compares favorably with surveys which predicted the correct outcome of the replication experiments in fewer than 60% of the 41 studies. Now, one interesting thing about this study is that one of the often cited advantages of using prediction markets is that they allow more participants and more diverse participants to contribute to the collective wisdom. But this study suggests that even for a given set of experts, prediction markets might be a superior way of synthesizing what they know than other methods like surveys. Now, the idea of using prediction markets for climate forecasting is not new. 35 years ago, the American economist Robin Hanson wrote an essay entitled "Could Gambling Save Science?", in which he floated the idea of using betting to form a consensus on scientific questions, including seasonal climate forecasting. That was one of the examples he mentioned. Since then, economists and climate scientists and legal scholars have advocated using prediction markets for climate and climate-related predictions. But the idea hasn't got that much traction. This is partly due to regulatory issues. Prediction markets do look a lot like recreational gambling, and also because many people assume that prediction markets for climate could be self-financing, like sports betting markets. But we'll now see how this is unlikely to be the case and what can be done about it. So there's been some experiments in using prediction markets for climate-related predictions. Back in 2011, a scientist at Sandia National Labs in the US, Mark Boslow, he used the Irish-based prediction market platform InTrade, which is now defunct, but back then it was a popular commercial prediction market platform. And he set up a market for the global temperature anomaly for the following year in 2012. So it's just the 1 year ahead global temperature anomaly. And he did this by creating a collection of contracts that would pay out $1 if the temperature anomaly exceeded a certain threshold. And then he had a whole range of thresholds at 0.05 degrees Celsius intervals, ranging from 0.3 degrees Celsius all the way up to 1.1 degrees Celsius. Now, InTrade used what's called a continuous double auction, which matched buyers and sellers of these contracts directly. And in the upper left corner here, you can see the order book for the contract that would pay out $1 if the temperature anomaly exceeded 0.55 degrees Celsius. Now, the highest bid to buy one of these contracts at this moment was 60 cents, while the lowest ask at which someone was willing to sell this contract was 75 cents. That means there was a 15-cent bid-ask spread, which is actually quite a big bid-ask spread. And this particular contract is the one with the lowest bid-ask spread. Some contracts had bid-ask spreads of 70, 80, or even 90 cents. If there is a collective consensus on what the probability of the anomaly exceeding a threshold is, it presumably lies somewhere within these bid-ask spreads. But given how wide they were, we can't estimate them with much precision. And this is... Oh, sorry, there's a question.
Yes, I see someone, Irene, you have maybe a question?
Well, a quick technical question. I assume that on that platform there were no transaction costs?
There were transaction costs, yes.
Okay.
And that's
okay.
And that also is an issue, which yeah.
Okay.
So, and this is a problem with these markets for specialized topics, is that they often don't attract much activity, which hinders price discovery. So InTrade was based in Ireland, and the UK also has some betting exchanges like Smarkets, and these are regulated by the Gambling Commission as gambling, because online gambling is legal in the UK if you have a license. In the US, there are now some commercial prediction market platforms that are classed as futures exchanges. So Kalshi and ForecastX have both been approved as futures exchanges by the CFTC, and they specialize in event contracts. However, they both had quite a hard time attracting traders to their more specialized markets. Kalshi, for example, apparently gets 3/4 of its volume and trading revenue from events contracts that are tied to sports events. Indeed, what Kalshi have effectively done is created a sports betting exchange that's regulated by the US federal government, because technically it's a futures exchange, whereas traditional sports gambling in the US is regulated by the individual states. ForecastX also has environmental and climate-related contracts, but they too don't see anything like the volume they get for other markets like those on political elections. So they currently have a market for how many hurricanes there'll be in the Atlantic this year, but the open interest on this market is only about 1/1000th of the open interest that they saw for their markets for the recent New York City, the mayoral primary election that just passed. Some of their other environmental markets, such as for global carbon dioxide emissions, attract more interest than that, but still only a few $1,000s of open interest. So very small compared to election betting and dwarfed by sports betting on platforms like Kalshi. So low activity or low liquidity is a recurring problem with prediction markets for more esoteric or specialized topics. And the underlying issue is that most of these prediction markets are zero sum. So the rewards of the people who get it right must come from the losses of people who get it wrong. And this is the same as in recreational gambling. And in fact, in many cases, as Irene alluded to, because there's either transaction costs, they're actually negative sum, either because the platform is charging some kind of commission, or with bookmakers, they take a cut from the way that the odds are set. So either way, in aggregate, the participants get back less than the total amount than they put in. These kinds of markets need to attract less informed participants to effectively subsidize information discovery, or maybe alternatively, people who want to hedge risks. Now, there are definitely some topics, like sports betting, that do attract lots of less informed participation. And where it's allowed, sports betting is a big industry. As I mentioned, Kalshi has created a futures market that's essentially evolving into a sports betting platform because that's where the activity is. And other topics like political elections and who's going to win the Oscars can also attract a reasonable amount of less informed trading. But specialized markets struggle to attract these so-called noise traders. And if the less informed participants, who ultimately provide the rewards for the more informed participants, don't show up, then there's no incentive for the more informed ones to show up either, because they aren't going to have anyone to trade with. And without frequent trades, there'll be large bid-ask spreads and stale prices. So it's hard to use these prediction markets to estimate probabilities. The important point is that in general, getting information isn't free. So that there might be subjects like sports where less informed gamblers are prepared to subsidize information discovery, but we can't rely on this. Information costs money, and prediction markets are not a free lunch. If we want information, we should be prepared to pay for it. Prediction markets, though, can be a more efficient mechanism for paying for this information. One way to pay for information is to make prediction markets positive sum by using a market maker that wants to lose money in return for good information. Now, lots of markets have market makers, they're participants that are always willing to trade, and bookmakers serve the role of market makers in traditional gambling. But these market makers are trying to set their prices to make money from participants. Alternatively, we can use an automated market maker that's specifically designed to reward participants for good information. One example uses the logarithmic market scoring rule. And this market maker is always prepared to buy and sell outcomes, quoting prices between 0 and 1 based on its relative exposure. That's how many of an outcome it sold compared to other outcomes. Now, while the market maker can lose money, it's important that its net loss is bounded. And this curve shows how the market maker adjusts prices as its relative exposure changes. Now, the total amount it gets paid for selling contracts for a particular outcome is the blue area under the curve. And if that particular outcome is the one that eventually occurs, it will have to pay out 1 unit for every contract sold. And the difference between what it has to pay out and what it collected is the gray area. That represents its net loss. And the net loss is bounded because as an outcome becomes very popular, its price, according to this pricing algorithm, approaches 1. If a market uses a market maker like this, it can function with a very small number of traders. In fact, it can function with only one single trader. That trader can keep buying outcomes until the market maker has adjusted its prices so that they match the probability beliefs of that trader. And it turns out in this case, it's exactly the same as if you just ask the trader for their probabilities, and then when the actual outcome is known, you reward that trader using a rule called the logarithmic score, which is a commonly used scoring rule for probability forecasts. Now, if you do only have one trader, you could arguably say this is a complicated way to get their opinion, and it would be easier just to ask them for their probabilities. But as soon as you have multiple traders, the advantage of using the market mechanism is that as well as rewarding the traders for good information, it also aggregates their information into a single unified forecast. So the prediction market has a competitive element, but it's more than just a forecasting tournament because of its ability to combine the forecasts. And ultimately, it rewards participants not simply for what they know, but for what they know that the other participants don't. Now, if the market maker is expecting to lose money, hoping to lose money, in fact, because that would mean the forecast is good, where is the money going to come from? Positive sum markets need sponsors who explicitly want to pay for information, either because the information is valuable to them or because they want to do it philanthropically to provide information as a public good. So in this sense, these kinds of markets are more akin to incentive or inducement prizes that are sometimes offered as a way to stimulate innovation. A famous historic inducement prize was the Longitude Reward that was offered by the British government in the 18th century to anyone who could work out how to measure longitude while at sea. It was eventually claimed by the watchmaker John Harrison, who created, for the time, an incredibly accurate marine chronometer that sea captains could use to figure out how far east or west they were of Greenwich. Captain James Cook took a version of Harrison's chronometer on his third round-the-world voyage in 1776. There is now a modern inducement prize that's also called the Longitude Prize in honor of the original Longitude Prize. One of their goals is to encourage the development of rapid testing for bacterial infection. There's also the X Prizes, which have been awarded for a range of achievements, from designing a lunar lander to healthcare challenges. So sponsored prediction markets can be thought of as an X Prize for climate forecasting, except that the market mechanism means that the prize doesn't have to be a winner-takes-all prize, but that it can be allocated in direct proportion to the contribution that each participant makes to improving the accuracy of the collective forecast. Since the participants in the market are not supposed to be a source of revenue, but a source of information and expertise, then it's no longer necessary for them to have to pay to take part. And this eliminates the regulatory hurdles associated with online gambling. While the mechanics are very similar to betting, legally it becomes something very different. So prediction markets can help us address the fragmentation of expertise and the problem of information asymmetry between the providers and users of climate forecasts. And Crucial is an initiative that uses prediction markets with expert participants to aggregate diverse climate forecasting models and expertise. It's based at Lancaster University's Management School, and the core team includes collaborators from the University of Exeter's Land, Environment, Economics and Policy Institute. The teams of experts that take part in Crucial's prediction markets don't have to pay to take part. We are not running an online gambling site. Instead, they are recruited for their expertise and allocated on-platform credits, which represent a share of funding from organizations that are sponsoring the markets. The markets use an automated market maker that rewards participants for their contributions to improving the accuracy of the collective forecasts. So this shows a market that Crucial is currently running to predict how many hurricanes will occur during this year's Atlantic hurricane season. There are 21 distinct outcomes, ranging from 0 hurricanes, then 1 hurricane, 2 hurricanes, and so on, up to an outcome covering 20 or more hurricanes. The outcomes are defined to be mutually exclusive and comprehensively exhaustive, which just means that they're designed so that only one will occur, but one must occur. The market maker gives a price to each outcome based on its relative popularity, And because the outcomes are mutually exclusive and comprehensively exhaustive, the prices always sum up to 1. Participants can define contracts that cover one or more of these outcomes, and the market maker will always quote a price. And users can define contracts like this to make it easier to trade markets with very large numbers of outcomes. So the prices can be interpreted as probabilities. So for example, the prices here imply that there's around a 12% chance that there will be exactly 8 hurricanes and a 38% chance that there will be 10 or more hurricanes. A similar market was run for last year's hurricane season, and this plot shows how the probability distribution implied by the market prices evolved from the day the market opened in December 2023 through the start of the hurricane season in June 2024, and then on through to the end of the hurricane season at the end of November 2024. As soon as the market opened, the median number of hurricanes implied by the market jumped to 8 hurricanes, which is slightly more than the long-run average of 6 hurricanes per season. Then, nothing much happened until April, when various forecasting groups that issue seasonal forecasts of hurricane activity predicted an active season with around 11 hurricanes. These forecasts are shown by the green dots. The market prices changed to reflect these forecasts, the median rising to around 11 before it fell back a bit to 10. In July, the first hurricane of the season, Hurricane Beryl, became the earliest Category 5 hurricane ever recorded, and that suggested that these forecasts of a very active season would be right. Beryl was followed by 2 more hurricanes, but then, in late August, which is usually the peak time for hurricane formation, the Atlantic basin went weirdly quiet. There were no storms, let alone hurricanes, forming for weeks. And during this time, we can see that the median number of hurricanes implied by the market started falling. Then later in September, there was a flurry of 6 hurricanes forming in close succession. These were followed by Oscar and Raphael towards the end of the season, bringing the total number to 11, which was in line with what many forecasters had predicted before the season began. This example shows how markets can incorporate new information, like the unusually quiet conditions in the Atlantic, in real time. And you can read more about it in a short research article that's just been published in Weather that we wrote with Ralph Tomey from Imperial College. Now, the concept can be extended into 2 dimensions. This is an example of a market that was run back in 2018 to simultaneously predict the monthly average daily temperature in the UK and the monthly rainfall. These are just 2 monthly statistics that are published by the UK Met Office. The outcome space was a grid divided into intervals of 0.2 degrees Celsius in temperature and 5 millimeters in rainfall, giving a total of over 5,000 possible outcomes. Now, a market with this many possible outcomes would never work without an automated market maker. But with an algorithmic market maker, it actually functions well. About 24 teams from British universities took part in this market, which was sponsored by Winton Group. And the teams were allocated credits to trade. But after the last of the markets had been settled, the teams that had accumulated the most credits were given cash rewards, courtesy of Winton. This movie is showing how prices for the market for June 2018 evolved from the opening of the market, which was in March, how they evolved through to the end of June. These prices can be interpreted as a joint probability distribution. The black dots, those are just historical Junes since 1910, which are there for reference. We can see how the market prices capture the negative correlation between rainfall and temperature. Hot Junes tend to be dry Junes. June 2018 was actually I think it was the 2nd hottest June on record up to that point. And you can see how the price distribution converges on the actual outcome as the participants incorporated new forecasts and then new observations. Many of the teams used an API to trade programmatically, and with it they could integrate their own models directly into their trading strategies. And that's very, very helpful for a market like this, which has thousands of outcomes. So these two-dimensional markets demonstrate the viability of running joint outcome markets with very large numbers of outcomes. And you can read more about the details of this market in a paper that was published in PLOS One. So since 2018, we've run a couple of dozen pilot markets. We've run markets for monthly values of an index for El Nino and La Nina, and we've run a market to predict UK wheat yields. We've run markets to predict the number of Atlantic hurricanes, and those markets I mentioned for monthly temperature and rainfall in the UK. And these pilot markets, they all had prediction horizons ranging from a couple of months to about 1 year. So the 24 pilot markets that we've run give us just enough data to begin to investigate how good these market-based forecasts are. An important characteristic we look for with probability forecasts is that they should be well calibrated. The frequencies of actual outcomes should match the predicted probabilities. Most of the markets produce probability distributions of continuous quantities. Now, if you have a probability distribution, then ideally the actual outcome should fall below the 10th percentile 10% of the time. It should fall below the 20th percentile 20% of the time, and so on, which means that if we plot the frequency with which a forecast or an actual outcome falls below a given quantile of the forecast distribution, we should get a diagonal line. With a finite sample, and 24 data points is not a huge sample, we expect to get deviations from the diagonal. So to assess the significance of these deviations, we can simulate perfectly calibrated forecasts by drawing synthetic outcomes from the forecast distributions. So for these synthetic outcomes, the forecasts are perfectly calibrated by construction. Now, in this plot, the blue line is the calibration curve for the 24 pilot markets, while the gray envelope shows the spread of calibration curves for sets of 24 simulated perfectly calibrated forecasts. The blue line falls within the envelope, so this analysis indicates that the market-based forecasts are consistent with being perfectly calibrated. Now, there's a couple of caveats on this result. Firstly, as I said, 24 forecasts isn't a huge sample. When you're verifying forecasts with horizons of months, it takes a while to build up a decent sample of verified forecasts. For a larger sample, the grey envelope would be narrower, and it's possible that would reveal meaningful deviations from perfect calibration. The other caveat is that none of the forecasts have prediction horizons beyond a year. Whether the calibration would persist for horizons of many years, we simply don't know unless we try it. But it's worth remembering that both those caveats apply to long-range climate forecasting in general, not just ones produced using a market mechanism. If you want to read more about this verification study, there's a paper in the Bulletin of the American Meteorological Society, which you can read. So, with funding from the SCOR Foundation, Crucial is now moving beyond running one-off pilot markets and towards establishing prediction markets as a permanent institution for synthesizing, summarizing, and disseminating climate expertise. In previous markets, the participants were classed as experimental subjects, which among other constraints meant that they had to be anonymous. In the new phase, we've recruited collaborating teams from universities and a private sector weather forecasting company. And as collaborators, their participation is public. And as well as taking part in the markets, they'll be involved in the governance of the markets and in collaborative research. The universities involved include some of the leading climate research institutions in the UK and a couple of US universities who are taking part as a single team. We've also put together a user steering group of organizations that use climate forecasts. This currently consists of Aon, Howden, and WTW from the reinsurance sector, and JBA Trust, which is an independent charity that supports research and skills in environmental risk management. So we're currently running 7 markets. One market I've mentioned is for the total number of hurricanes for this year's Atlantic hurricane season. And there's another 6 markets, a strip of 6 markets to predict 3 monthly averages of an El Nino index. This strip goes out to the beginning of 2027 because it's quite difficult to predict the state of El Nino through Northern Hemisphere spring. It's called the spring predictability barrier. And we want to give participants an incentive to try and figure out whether they can improve El Nino predictions beyond this barrier. This plot shows the market for the average value of this El Nino index that we are using for the period. This is the average for June, July, and August 2026, a year from now. So this is an index that measures the sea surface temperature anomaly in the tropical Pacific. High positive values indicate an El Nino, and negative values indicate a La Nina. The forecast currently suggests there's a slight bias towards cooler La Nina conditions, but the current prediction is quite close to neutral. Forecasting El Nino and La Nina events is valuable because they have an impact on weather around the globe. And in fact, they're the single biggest driver of year-to-year climate variability. And so now I would like to hand over to Kim, who's going to discuss the future of Crucial and what we plan to do with it.
Thanks, Mark. So we at Crucial want to establish sponsored expert prediction markets as a recognized way of eliciting and aggregating climate forecasting expertise to produce collective predictions of climate-related risks. And relatedly, the aim is to develop Crucial into a new type of scientific institution for funding incentive-aligned collective forecasts. As part of this aim, we want to extend the horizon of markets to predict longer-range climate outcomes. Possible markets include markets to predict global temperature, Arctic sea ice cover, sea level rise, and the strength of the thermohaline circulation, which is responsible for Northern Europe's relatively stable and mild climate. We also want to produce market-based forecasts of greenhouse gas emissions and concentrations, as well as related things, such as the market penetration of electric vehicles and of renewable energy. In principle, a very wide range of climate-related variables are candidates, as long as, however, they are contractable. There must be a well-defined target variable that can be specified as the one that will be used to settle the market, such that all participants know exactly what it is they are attempting to forecast. And this needs to be, in a technical sense, non-manipulable and verifiable by a third party. Next slide, Mark, please. We also want to create markets that address the problem of circularity, as Mark mentioned earlier. For example, if you have a forecast that just predicts the global temperature anomaly, and let's suppose it predicts that over the next 30 years, the temperature will only rise by 1.5 degrees Celsius. We won't know whether that is because climate sensitivity to greenhouse gases is lower than widely believed, or whether the forecast implicitly assumes drastic political, regulatory, and enforcement action to reduce greenhouse gas emissions. If those two scenarios cannot be differentiated or teased apart, then the information is of limited use to policymakers, whether they're in the public sphere or in the corporate sphere. Having already demonstrated the viability of joint outcome markets in the article that Mark referred to, which this has large numbers of potential outcomes, we want to use this idea to produce joint markets for greenhouse gas concentrations, particularly CO2, and climate variables such as the global temperature anomaly. By producing joint forecasts of CO2 concentration and global temperature, we get around the problem of circularity. Such markets could also be used to assign probabilities to emission scenarios and to produce estimates of the transit sensitivity of climate to greenhouse gases. Next slide, please, Mark. The prediction markets we have run so far have all had prediction horizons of not much more than 1 year ahead. The longest currently active live market we have is just over 1.5 years. While there are plenty of climate-related risks for which forecasts at the 12-month horizon are useful, or thereabouts 12 months, we also want to use prediction markets to forecast long-range climate change, which means eventually running markets for years and for decades into the future. This creates a new set of challenges which most prediction markets don't have to deal with. However, there are plenty of examples of financial contracts, such as bonds, pensions, mortgages, and so forth, which have long multi-decadal horizons. So in principle, the challenges are not insurmountable. One factor that is clearly important is the time value of money. Buying a contract for 50 cents that will pay out €1 next week is potentially a good deal. But if the payout isn't for 20 years, then it is not particularly attractive. Even though our markets are not pay to play, this time value of money aspect could still distort the decisions of participants by drawing them toward the shorter range markets and toward ignoring the longer range markets. This problem can be mitigated by denominating the market in an asset that accrues interest at the risk-free rate, I would propose. We already denominate our markets in on-platform credits, and these credits are backed by a pool of research funding. If this pool accrues interest, then the cash value of the credits can appreciate in accordance with the risk-free rate. Another factor is that participants need to be confident that Crucial is going to be around until the time that the market expires and settles. This is the counterparty risk known in the financial domain. Basing Crucial in a university helps with this. Other protections we envision include placing the funding pool in a single-purpose trust and also having wind-up procedures which specify how a market will be settled if it has to be ended prematurely. We also need to be confident that any data or observations needed to settle a market will be available. For example, there are several organizations that maintain time series of global temperature anomalies, the UK Met Office, NOAA, NASA, and so on. These indices are very similar and highly correlated, but they are slightly different. Which one will be used to settle a market is specified when we launch a market, but we also build in a contingency alternative if the chosen index is no longer available for some reason. And we have a scientific advisory committee who can act to resolve questions that require judgment in deciding which alternative series would be used in a specific instance. There is a question over how effective incentives are as the time horizons get longer. Having the participants be institutions and organizations rather than individuals helps in this respect, as these are entities that have longer time horizons than individuals. For instance, as is the case for university endowments. But individuals can hopefully be incentivized to work today for rewards that they might not receive for decades. After all, the entire premise of workplace pensions rests on this assumption. The size of the incentives will also be a factor. So far, the sponsorship amounts have been enough to motivate people to bring information they already have or can adapt with modest effort. But with larger sponsorship amounts, these markets, like the X Prize, could actually steer the direction of research toward creating new models and collecting new data to improve forecasts of the most pressing climate risks. Next slide, please, Mark. To sum up, we believe sponsored expert prediction markets could become a new type of scientific institution for synthesizing climate forecasting expertise and for allocating funding for climate forecasting research. They combine the idea of inducement prizes, like the X Prize, with the ability of markets to aggregate information. When the primary deliverable research is a forecast, prediction markets offer a more effective way to synthesize information and expertise, and a more efficient and accountable way to distribute research funding. Next slide, please, Mark. And so we have a series of publications, the last funded under the funding of SCOR Foundation, that elaborate many of the issues that have been discussing so far in the webinar, and we direct you to the additional details contained in those publications. And with that, I think we are moving toward the Q&A part of this webinar.
Thank you so much, Mark. Thank you so much, Kim. It was very insightful, very interesting, and always also very pedagogical, so that not only those having either an experience of such predictability markets in finance, for example, as myself, than other having no experience. I think I just know figuring out what could be such predictive markets. I will not spend too much time. Let me look if in the conversation there are some questions already asked to you. And okay. We have one question from Kwame Bandele, who says he's in Chicago. I hope it's not so hot as in Europe, where they are building a quantum computer for climate forecasting. What makes quantum computing better suited for this task?
I think we've lost.
Kim, Mark, you have the floor.
My honest answer is I'm not familiar enough with quantum computing to know what specific advantages there'll be. I mean, weather and climate forecasting historically has always been at the, if you like, pushing the boundaries of computer performance. You know, for a long time, if you looked up where the most powerful supercomputers were in the world, sort of in the top 10, many of them would be weather forecasting agencies like the European Centre for Medium Range Weather Forecasting and such like that. I think that's become fuzzier now with cloud computing as what constitutes a supercomputer, but they've always really been a big there's been a big demand for better performance to simulate the atmosphere at higher and higher resolutions, and also to run what are called ensembles when you run multiple simulations with slightly different initial conditions or with slightly different model parameterizations to try and understand the uncertainty in the forecast. So you don't just want to produce one forecast, you want to produce a whole ensemble of forecasts with slightly different initial conditions. If they all do more or less the same thing, then you can be more confident that that's what the weather's going to do. If they all do very different things, then you know that the atmosphere is in a particularly unpredictable state. So beyond being just another way of improving computer performance, I don't know whether quantum computing provides extra specific advantages. Sorry.
Do you have?
Yes, and I don't have any. I'm the economist in this. I defer to Mark's expertise on this particular question.
Oh, I can imagine. But maybe I am not sure that a question of predictability markets is really could really be improved or not by quantum computer, because from my point of view is more it has more to do with big data and how to deal with big data, but which suppose to already own this data. And for me, part of the interest of predictability markets is that we don't know everything. We don't have all the data we would need for a good model, and therefore we have also to rely on expert judgment and to cross that expert judgment. But I leave you say if I am wrong or right in saying that.
Yeah, I think that is a point. You've got to you are limited by how good your physical models are, and just being able to run a physical model faster doesn't remove the shortcomings in the physical model.
Yeah. Okay, I see that Irene, you have a question. You have the floor, Irene.
Actually, I do have lots of questions. Apologies.
Okay,
I think
let us
limit myself to
begin.
three.
Maybe you can group perhaps two or three first questions, and then we can deal later with the others.
Definitely. I try to make the easy or the quick ones first. So one question is, have you considered introducing an AI bot as a parallel better in that system? Because you were talking about the entire market being about teasing out tacit knowledge, and that's one of the things that we told about AI, that it is actually doing exactly that, extracting tacit knowledge.
Kim, would you like to?
I can go with that. So we have been speaking with a collaborator who has explicitly been working on experiments where they integrate into a single market human traders with AI traders, and so we're very interested in that. And so I think any one of our participants in our markets can use AI models themselves to generate probability distributions, and then they have their own discretion as to how they use that to drive trading decisions. Okay, so there's nothing preventing that. And in fact, if you look at our suite of participants at this very moment, there is one team, the US-based team, that combines in the same team expertise from one university center that is in dynamic models, and the other half of the team is a specialist in machine learning and AI. So already you have this ability within the same team to self-select into the you might call the regimes or the intervals of the outcome, where each modeling approach has its advantages. Okay, and on a larger scale, we feel that our prediction markets allow a kind of a self-selection of this nature, but also across participants, not only within teams. So if one team believes that they have a particularly good model of the tail of a distribution, they can focus their trading efforts on the tail, where they believe they have their informational advantage and modeling advantage. I think this is an aspect of prediction markets that hasn't really been communicated very widely and very effectively as an advantage relative to surveys. Because when you survey people or survey experts, they will provide you with a complete distribution. And then the third party that is administrating the survey has to somehow decide relative weightings, if they do so at all, depart from equal weighting. So I think this is an opportunity. It's part of the package that the prediction market platform offers as a kind of an extension beyond the prevailing state of the art, survey-based state of the art. I hope that answers your question.
I think it does. Yes, thank you very much. And my second question would be around the communication among the participants. So are they able to see what the other ones are betting? Is there like a track that you can watch to see what others are doing, or is it completely anonymized?
We can see there. We divulge to the. It's anonymous. You see volumes. You see volumes. Aggregate volumes are visible, but. And you can reverse engineer those from the prices, in fact. But where each party is concentrating their efforts, that is not made public. But communication among the participants is not. We're not monitoring that. We don't discourage that. Mark, would you like to add?
We don't hear you, Mark. You should go on mute.
Yeah, so the participants can see prices from which, as Kim said, they can reverse engineer open interest, basically, but they don't know who has that open interest. But as Kim said, I'm sure they do talk amongst themselves because they belong to the climate forecasting community, and so there's no way we can control that, and there's no way we're going to try.
And that brings me maybe to my last question for the time being is, are you happy with the size of your audience, or would you like to include other participants? If not, why not? What's holding you back?
So I think 10, 10 is certainly sufficient. 10 teams, which actually the total number of people who are participating is dozens. 10 teams is sufficient, but we would certainly like it to be bigger and to grow over time. What we do want to be able to say, though, is that we want to know who they are, and we want them to be a well-defined, if you like, set of experts, so that we can say this market represents an objective consensus view of these experts. So as I said, they're currently 8 British universities, 2 American universities, private company. Would certainly, I mean, I envisage that growing to dozens. We don't want to turn it into a sort of 10,000 participant kind of thing, but certainly if it could represent, if there are over 100 universities in the UK, not all of them do climate stuff, but that kind of scale, we'd certainly like to grow towards that.
Or even a French one.
Oh yeah, yeah, absolutely. I mean, our bias, I should have said, our bias, they are mainly British universities, but that's only because that's where our network was, and who we initially recruited. We have reached out to a couple of French universities. We, as mentioned, we have 2 American universities. We would definitely be open to having more non-UK universities from anywhere, the European Union. We would definitely be open to that. It's just a question of having the network, if you like, to make them aware that this is going on and to bring them on board. So if you know of any universities that might be interested, we would love to have an introduction.
I can reassure you, Mark and Kim, we all are biased in some sense or another one by definition, and of course this cannot be a critic by definition. Maybe I have a question of Isabelle Prolillon, who asks you, is Crucial system implicitly based on sensors, satellite, image, etc.? What is the governance in sensors, and are the forecast algorithm open source? In synthesis, can you elaborate around the neutrality information in making prices? Probably the last question, part of the question is the most important. I think the first one you have already partly answered, but you may perhaps come back on that point.
Thank you, Philippe.
Maybe I will lead just because my microphone is on at this time. I think it depends entirely on what markets we're talking about. At the moment, we have Atlantic hurricane, in terms of live markets right now, we have Atlantic hurricane markets, and then we have ENSO markets based on the Ronnie index. So my understanding is that if we were to define new markets where the sort of the independent adjudication of how many of the events or what is the index that is being contracted upon, if that would involve satellite technology, then or satellite imagery, etc., then I suppose the answer would be yes. So it depends entirely on what markets we're considering, and I think there is a certain amount of satellite imagery being used more generally in weather sensor systems, but I think we can't give a single answer that 100% yes or 100% no. That depends on the case, the market case. And your question around is the forecast algorithm open source? Well, we can talk about the algorithmic market maker algorithm, which is the logarithmic logarithmic market scoring rule that has been in the open, published, and available for all, and is in use in a variety of sponsored markets already. and in the sort of the experimental literature and in the research literature on prediction markets. So that is open source. With regard to each participating team's sort of algorithmic resources and the algorithms they use, I think that again is a team by team question. Some will be open source, some will not be open source. And in synthesis, can you elaborate around the neutrality of the information in making prices? I think with regard to the index that we use to resolve a market, that is from independent sources. I referred earlier to the need for contractability, that it needs to be non-manipulable and independently verifiable by a third party. I think that satisfies your concerns regarding neutrality. But in terms of what information sources individual teams bring to bear in their trading activity, that is not transparent, although we can get retrospective sort of narrative explanations, certainly from the teams, as to what sources of information they bring to bear. Mark, could you sort of complete the story there, please?
Yeah, in terms of, say, satellites and stuff, I suppose that all the markets we're currently running indirectly use satellite information. So, for example, with the hurricane market, that's how many hurricanes are there in the Atlantic, but deciding whether a tropical storm is a hurricane or not depends on its wind speeds, and one of the ways that they measure wind speeds is using satellite information. It's might be very modulated by models and stuff, but in that particular market, it's the National Hurricane Center. It's the U.S. National Hurricane Center is designated by the World Meteorological Organization as being the center that gets to say whether a storm is a hurricane or not. So they're the authority on how many hurricanes there are in the Atlantic. And similarly for the El Nino index, that's based on sea surface temperatures, which is based on, as I understand it, reconstructions of the sea surface temperatures using models, which also includes, amongst other things, satellite data. And that's another number that is published by the National Oceanographic and Atmospheres Administration in the US. And so when we are designing a market, one of the considerations is who is the authority? What is the agency that publishes this number? Is it an accepted number, and everybody knows that this is the agency? This is it's their call on what the number is.
Maybe can I ask?
Thank you.
Basics. That is, here we are building something which we could say, that you made reference to him, to an Arrow de Breu world, where in fact Arrow de Breu demonstrated that we'll get efficient market, but of course by assuming that economic agents are at least rational, or at least the marginal agent who is arbitraging lastly all the market is itself rational. When I turn to the market we will be building with you, and we will support you to build. I have a question, because in fact, and we know that also in insurance and reinsurance, gathering stupid persons, not aware of risk, etc., of course, provide you with diversification, but don't provide you with good diversification. It provide you to be more exposed to extreme risk than to lower risk. And how will you be able to have an opinion on the different team and to be sure that they are informed, because in order to get a collective information, at least all the participants should be, of course, rational, should be informed, etc. I just take the example of Kalshi, which was very interesting over the last months with the two elections, which were one of Trump and the other of the Pope. Kalshi was relatively successful in alerting us relatively in advance, than despite the surveys, in fact, at the end of the game, it was Trump who was preferred. And therefore, they first, before the surveys, pointed to the fact that the majority was in favor on Trump. Of course, most of the people who were betting on Kalshi had some information on Trump. In any case, they just were listening the friends, the other professors, reading newspaper, etc. When I turned to the Pope, of course, Kalshi was totally wrong, because Leon XIV, who has been elected, was exactly outside even any consideration. It was in the list, but of course with just a marginal bet on him, because no one of us, especially if we take all the participants to see the webinar, have any idea what is happening inside the Rome curie of the Saint-Siège, and therefore this was information of absolutely uninformed person, and of course at the end of the game provided no value added to what we knew already when reading the newspaper. And therefore my question, and how are you sure that all the mechanisms you are putting in place just put exactly informed people in the scope of this platform, and therefore participating to the prediction of the market?
Mark, would you like to start with that? I have something to add, but I'm
okay. So my argument would be, because of the way that the markets are sponsored, we don't have this imperative to attract uninformed people in the same way that platforms like Kalshi do, because these are sponsored markets, so that we have this luxury, if you like, of being able to recruit people who at least notionally should know something about climate. And so really, if you look at the participants that we have participating in the market, those institutions, they're the same kinds of institutions that contribute to things like the IPCC reports and these other ways of forming consensus forecasts of climate. Because I think we have to compare what we're doing. The comparison is not necessarily some ideal, but the next best thing, which is, how do we currently form consensus climate forecasts? We use processes like the IPCC committees and peer review and all of this kind of thing, and that's the comparison, rather than some idealized world of hyper rational, hyper informed people. So saying, well, do we at least have a chance of being better than that? Do we at least solve some of the problems that they have? So I don't know if that answers your question, Philippe, and if Kim,
no, it partly answers my question. Maybe on some point, what I had also in mind, that you could be in competition. That is another, for example, university may want to launch a platform just being concurrent to your one. And therefore, at this point, if you are both in competition, the question will be, who will gather the participation of the best informed people in order to get the best informed collective prediction. Maybe you can ask to me, at this point in time, we have not so many institution people which could productively contribute to the platform. Therefore, the problem I am mentioning is just marginal. But it was my preoccupation when when reading your papers, etc., because it's so interesting. Of course, we are betting on collective intelligence, and part of collective intelligence is also competition. And when we know in competition, it's also, as Schumpeter said, is partly destructive also and partly constructive.
Could I add? So
yeah.
with regard to Irene Merck's question, are we happy to have additional further research teams participating? The answer is yes. We do have implicit sort of quality and expertise criteria which are amorphous, so they're not set in stone. We are happy to consider teams that have, let's say, very strong machine learning skills, that's a track record in a related area. We can potentially onboard such a team, but starting them off with a smaller credit allocation, they can participate in certain markets, designated markets, and as they prove their competence or their capability in these markets, we can give them a larger and larger access to more markets and a larger credit allocation. So I think we have mechanisms in mind to onboard previously unrecognized talent or previously unrecognized expertise. So that is one aspect of it. And in fact, I too have been thinking about the prediction market outcomes concerning the Pope, the conclave for the Pope, and my impression is that the prediction market forecast was 1% for this particular candidate who then won out. And well, the thought process that I went through there is, well, is this a well calibrated forecast? What other we should plot this on the same sort of calibration unit square along with other forecasts of this nature, and then see, is it 1% indicates 1 in 100, right? So I think this one instance is not enough to really to evaluate the quality of that forecast, as 1% outcomes do occur. Right? They do occur.
Yes. They too. Maybe we are quite at the end of our webinar. I have one further question.
There is a question from Nicolas Carey.
Yes, from Nicolas Carey, which is a typical, it will very much please the actuaries. I read the question maybe, or Nicolas, you want to ask it directly? No. Yes, please, Nicolas, you have the floor.
Let me open my station. Yes. No, I was, hi everyone, so thanks a lot first. No, I was just wondering if by having mainly or only expert in your panel, you don't, by construction, underestimate the volatility of the distribution, and if you had the opportunity, the chance to test it, to back up and to see if the volatility of your distribution was in line with the final one, basically.
You mean, Nicolas, you mean on past events and past years, in fact, comparing both?
Yes, it was possible to compare or not to see something like automatic bias. Yeah.
Mark, do you want to lead again, please?
Yeah. Do you want to go first, Kim?
No.
Okay.
Handing to you.
So in terms of, I mean, we have done that calibration study on the 24 forecast. One of the problems that we run into here all the time is because even when you're doing seasonal forecasts a few months ahead, it takes a while to collect data where you can address these questions with any confidence. But so far, I mean, in terms of as much as we've done a calibration study, it looks as if I can wave my hands and say, look, there it's consistent with being calibrated. So those distributions look as if they're not underspread. The question, though, I think it's a good question of if we just have experts, and also what is an expert, because as Kim was saying, is that, if you're a machine learning expert, maybe you don't know much about climate. Is that enough? So the decision how I would like to see it evolve is that if you like, the definition of expert gets broadened as we build confidence that the market is working, as people become familiar with it. I would like to see the range of people participating broadened, so not just hardcore climate experts, but as Kim said, AI experts, machine learning experts, statisticians, to make that broader, because I do think that they can bring things to these prediction problems that the pure climate people may overlook. So if you like it, but this is partly it's the baby steps thing that we're trying to build familiarity and then build the thing out. We don't. I think it would be actually harder from a regulatory standpoint if we made it a free for all, pay to play market. Then there's massive regulatory hurdles with that. So because it's a sponsored market, we have to that imposes a restriction on how many people we can have. But we would like to see that broadened over time. Kim?
Yes. So if you'll permit me, so we have looked at a number, well, the increase in the number of what are called many analysts one data set studies. Now, these are not forecasting studies. These are studies where a single data set is made available to multiple statistically competent research teams, or econometrically competent research teams, and they are given one or more predefined hypotheses to test, and one finds that the heterogeneity of the results scales with the number of teams participating. So we feel that, or at least I on my side feel that the more teams we have, we're more likely to capture the volatility that you're referring to when compared to using a single team. And the default at least in contracting for and purchasing climate forecasts today is you go to a single supplier, right? And so compared to that, I think we're in a better position to capture, consequences of diverse modeling choices. Okay. And I mean, there are some as yet unanswered questions about how let's say the dispersion of our forecast scales with the horizon when we have multiple teams participating. And quite frankly, I'm very, very keen to and very excited to see that distribution when we push the number and the horizon of these markets out, so that we have a strip of markets, as I think Mark described, going out 10 years or more. How the dispersion of that forecast, that prediction market forecast, scales with the horizon. I'm very excited to see that because at the moment we don't have mechanisms for bringing, for seeing that, for bringing that into existence without this, pushing the crucial markets out that far. So I think in these two of compare, what's the reference point? What are we comparing it to? And then, well, the sort of the unanswered question of, well, what is the realistic climate predictability horizon? And I think that is something that these prediction markets can begin to answer.
Okay.
Okay. Thanks a lot.
I would like to pursue this discussion because we are entering probably with an interaction between actuaries and your research and project. But I have to confess that I have to stop here. We have promised to all auditors we will not go beyond 1.5 hours in any case. I would like to thank you very much, Mark and Kim. It was very fascinating. I just some comment, fascinating content. Thank you for this presentation. Thanks for the interesting presentation and discussion. Ciao. Thanks a lot. Therefore, we were all very happy and you have stimulated us. And of course, we will look at the result, and of course, Kim, we will look at what we learn from the data at 10 years and 20 years, as you said, predictability of the climate. So I thank you so much. For all auditors. You can continue to follow the research of Mark and Kim on our website, the foundation website. We are putting sometimes information on articles, information on also any activity and future activity. In any case, we will continue to inform you of what are the results of Mark and Kim. It's so fascinating, and therefore I thank also you all auditors, and let us just wait for the future results with some how to say, excitement. So I say goodbye and thank you.
Goodbye. Thank you very much, Mark, Kim.
Thank you.
Thank you.
Bye-bye.
Thank you very much.
Thank you, everyone. Thank you, everyone.
Bye-bye.
Bye.
Bye-bye.